So hopefully you're getting a better feeling for charge and the potential energy, what those actually mean in a circuit, the current, resistance, the relationship between those, the Ohm's law, which is the voltage is equal to current times resistance, and how much power gets used. Because I want to concentrate a little bit and give you some more focused exercises on some trickier circuits. Circuits that are in series, for instance, these ones where you can follow the path around, or those that are in parallel where you have multiple paths to get down through. As a matter of fact, the more difficult ones, or the more, not difficult, but the ones that are more like a puzzle, is what I want to focus on for you on today's assignment. Just a couple of those kinds of possibilities. Here I've got a couple examples of strategies that when they're both series and there's part of their circuit is in parallel as well. So you might see, for instance, a circuit that looks like this one. You have an 8 ohm resistor that's going in. Let's make this nice and big so that you can see that. Okay. That you've got an 8 ohm resistor here, and then you got 2 parallel 8 ohm resistors. So the idea is, what do we do with this? How do I get one of these to get to a single equivalent resistor so that I can then use my V equals IR formula? Well, if I know that, for instance, I have 2 resistors in parallel, we know that 1 over this one, 1/8 plus 1/8 is what those 2 equivalents are. An equivalent resistor is 1/8 plus 1/8, and then whatever that ends up being, flip that fraction. So let's think about that for a second, okay? So if I've got the equivalent resistor here would be 1 over 8 ohms plus 1 over 8 ohms. Okay, so that ends up being 1/4. As a matter of fact, that for parallel circuits, 1 over the resistance is the sum of all the inverses of the resistance. So if I had 1/8 plus 1/8, it becomes 1/4, and that flipped then becomes the equivalent resistance. So if I come over here, now it's just an 8 ohm plus a 4 ohm resistor, and those are in series, so that the equivalent resistor is right over here. Or the total resistance is just a 12 ohm resistance. So they had to look at certain portions of those and think of the rules to then represent them to find out what the equivalent resistors were, and then they were able to add those up. If you can get them in series, that's easy because they just add up. If they're parallel, then trying to get them to use the 1 over all their, or the sum of all their inverses is the inverse of that is the equivalent. Well, let's try this guy. I'm going to take this guy out of here for a sec, and let's try this one down here in the bottom and try some strategies there. Okay, got these in your notes. Here you got 2 things that are parallel. You got another set of things that are parallel up here. Probably because these are multiples compared to this. Let's focus right here on this small set of parallel ones. So the equivalent resistor, actually 1 over that equivalent, is going to be 1 over each of those values. Is 1/4. That's resistance 1 plus 1/4. So that's going to be 2/4 or 1/2. So what's the equivalent here? Well, 1 over that is the value of the equivalent resistor. That's 2. So if I look over here, it became 2. So now I've got 4, and then the equivalent resistor here is 2. So that's going to end up being what? They're in series, so they just add. So then this top resistor becomes 6, and the bottom one is also 6. So what's the equivalent resistor for the 2 of those? Well, 1 over the equivalent resistor is equal to 1/6 plus 1/6. That's 2/6 or 1/3, right? So 1 over that is what the equivalent is, 6/2 or 3. That's what we see. So that's the kind of strategies you're going to want to do to go in there. Find those portions that you can say, oh, those are easy to figure out. I can do like 2 parallel resistors with each other and reduce that down to 1. Or if I see a long series, for instance, right here, I can reduce those just by adding them. And then see what you can do to get a final equivalent. And sometimes you may have to use some other information as well. But that's usually the strategies as we're going to go out, okay? They're going to get some problems like that. So that's the first part of today's worksheet.